Hello students, welcome back. Previously, we went through the theory of the elasticity of demand. Here's a definition. The negative of the relative of rate of change for quantity of demand over the relative rate of change for price. But of course, this is a bit too complicated, as you can see, too many fractions. So we typically use the simplified form. Okay, let's copy and paste the simplified form here. This one, that's the definition. Too complicated, so let's use either this simplified form or that simplified form. Let's see. Let's rewrite like this and put some space in between. Okay, we are ready. Let's go. Here's an example problem. Suppose that the demand of a certain product can be modeled as follows, where P is the price and Q is the demand. And the relation it gave me is, something very simple. P is 1000 over 1 plus Q squared. So we have an explicit expression here, not an implicit equation where P and Q are intertwined. In that case, we'll have to use this, P prime, Q prime. But in this case, looks like using this is a bit more appropriate. Let's do it that way. So here's the elasticity formula, and we're going to use the first formula. Oops. Okay, all right. Too many fractions, so let me expand the font. So this quantity here times the derivative. And that's the computation you want to do. All right? Everybody agrees? Okay, let's calculate the derivative. P is given like this, so P is 1000 over that. So it can be written as 1000 times 1 plus Q to the negative second power. So then you can calculate the derivative a little bit more straightforward fashion. So the derivative is negative 2000. 2 comes out as coefficient. 1 plus Q to the negative third power. Make sense? Power comes out as coefficient and subtract from the power. And then by chain rule, we have to multiply the derivative of the inside. What's the derivative of the inside? It's 1. This coefficient is 1. So you can write like this. All right, we have the derivative here. Shall I plug that over here? Like this? The answer is no. This is wrong. The derivative I need is dq dp. The derivative I calculated here is dp dq. Oh, it's reversed. It's upside down. Okay, I can make it right. dq dp is nothing more than reciprocal of this. Oh, by the way, it would have been a bit easier if I made this observation first. So negative third power, so in traditional expression, third power goes to denominator, and it made it that much easier to take the reciprocal. So negative of 1 plus Q to the third power over 2000. So can I plug this one in over here? Yes, I can. Yes, I can do that. But then again, I took the derivative, so I'm free to plug in numbers. And what is Q value? The problem gave me 19, right? So this whole thing is am I doing it right? 1 plus 19 to the third power. So 20 to the third power. Negative of 8,000 over 2,000 was therefore. Did I do this right? Or am I missing a 0 or something? Yeah, that's right. So, okay, all right. Yes, I could have plugged this expression inside and then plug in numbers later, but why would I do that? If I plug in the number before taking the derivative, then that could be a problem because I cannot take the derivative anymore. But once I took the derivative, I'm free to plug in numbers. So I'm going to plug in -4 right here. All right, that took care of this. Now how about this? Okay, all right, let's do that. So this is there. Start from here. P is that. So when Q is 19, this is 1,000 over 1 plus 19 to the second power, right? Remember, I'm going to calculate, so I have to plug in numbers. Q is 19. I know that. P, that's what I have to calculate. That's what I'm doing here. And then that is 1,000 over, let's see, 20 to the second power, 400. That's 10 over 4, 5 halves, 2.5. Yeah, all right. That's the computation. So there's a formula. And then I have to get negative P over Q. And P is 2.5. And Q is 19. Yeah, I'm going to plug those in. And this dQ dP, well, take the derivative and not blindly put that in. We have to take the reciprocal because I want dQ dP. Plug in the numbers, so I get -4. So that's -4, and there's 2.5, and then down here 19. Yeah, okay. Let's plug in the numbers. Here's a conclusion, and then this is 2.5, and then that's 19, and then this is 84, right? Okay, and this computation is 0.52 something. So this product is inelastic. Okay, that's the formula. And then the derivative computation, we do dp dq by straight up derivative computation, and then take the reciprocal because I am dq dp, and remember to plug in the numbers because eventually I have to plug in numbers. This is not the derivative computation. Let us calculate the p-value. And here's the conclusion. Okay, there goes the solution. And why did I name it as solution 1? Because I use this method. Now, do I have enough time for the second method? Let me try. If I don't complete it within time, then I'll just stop and then ask you to complete later. Okay, elasticity formula that I'm using is this. So this is going to be q prime over p prime. Make sense? Okay, from here let's calculate the derivative, and this is not the derivative computation we are doing. P is, this power expression. This becomes a power expression, okay, so that I can take the derivative. But this is not correct derivative computation. We take the derivative with respect to t, so this one is just p prime. And then take the derivative by q, and by chain rule, q prime pops up. Make sense? And then we want q prime over p prime. So let's calculate q prime over p prime. By the way, I keep forgetting this. The 2000 over 1 plus q to the third power in traditional expression. Okay, this is conclusion. And from here, let's calculate q prime over p prime. Q prime over p prime. And I have to flip this one to the other side. 1 plus q to the third power over 2000. So if I flip this one over, then that is equal to this time p prime. Yeah? Flip that onto the other side. That's what I got. And then divide by p prime. This thing. And then you can plug in numbers, you see. And that's 19. And remember the computation? 8,000 over 2,000, you get -4. Of course, the same answer as before. So instead of taking the derivative just directly, we take the derivative implicitly and get the relationship between p prime and q prime. And eventually what you want is the ratio q prime over p prime. I don't need all those, too redundant. And then this computation stays the same. Yeah, plug in q value. So in the end, we have the same computation, except that the formula we use is this, and then the conclusion. I guess I completed. That's nice.